Hey there, space enthusiasts and dreamers. Have you ever gazed up at the stars and wondered what it would be like to travel to distant planets? Pinch your nose and squint your eyes because we're about to dive into a mind-bending concept that could make those interstellar dreams a reality: cryogenic sleep. Now, before you start having flashbacks to cheesy sci-fi movies, let's get one thing straight. This isn't just the stuff of Hollywood imagination anymore. Cryogenic sleep, also known as suspended animation, is a cutting-edge field of research that's capturing the attention of scientists, space agencies, and futurists alike. But here's where it gets really wild. Cryogenic sleep isn't just about space travel. It's about cheating death itself. Yeah, you heard that right. We're talking about the ultimate snooze button on the alarm clock of mortality. Throughout history, humans have been obsessed with the idea of living forever. From ancient alchemists searching for the elixir of life to modern-day tech billionaires pouring fortunes into longevity research, we've always been trying to outrun the Grim Reaper. Cryogenic sleep might just be our most ambitious attempt yet. Imagine being able to pause your life, like hitting the freeze frame button on a movie. Your biological processes would grind to a halt, and time itself would seem to stop, at least for you. It's like taking a pit stop in the race of life, while the rest of the world keeps on spinning. So what exactly is cryogenic sleep? In simple terms, it's the idea of preserving a human body at extremely low temperatures with the goal of reviving them later. It's like putting yourself in the ultimate deep freeze, only to thaw out years, decades, or even centuries later. Now, I know what you're thinking. Isn't that just freezing someone? Well, yes and no. The key here is preservation. We're not talking about turning people into human popsicles. The goal is to cool the body down to a point where all biological processes slow to a crawl, without causing the kind of damage that typically occurs when cells freeze. This is where things get tricky, and where the real scientific challenge lies. You see, when water freezes, it expands. And guess what your body is mostly made of? Yep, water. So if we were to simply freeze a person, the ice crystals forming in their cells would burst them like overfilled water balloons. Not exactly the fountain of youth we're looking for. That's why researchers are exploring various techniques to prevent ice crystal formation. One promising approach involves replacing some of the water in cells with cryoprotectants, essentially biological antifreeze. These substances could potentially allow us to cool the body to extremely low temperatures without the destructive effects of freezing. But here's where cryogenic sleep really captures the imagination: its potential for space travel. Imagine you climb into a sleek, high-tech pod on Earth, close your eyes, and the next thing you know, you're waking up on Mars. No need to worry about going stir-crazy on a years-long journey, no concerns about running out of supplies, and no fear of aging while your family back on Earth moves on without you. It's the ultimate cheat code for space exploration. With cryogenic sleep, we could potentially send humans to the farthest reaches of our solar system and maybe even beyond. But let's not get ahead of ourselves. As amazing as all this sounds, we're not quite there yet. Cryogenic sleep is still largely theoretical, with many hurdles to overcome before we can start packing our bags for interstellar slumber parties. That being said, the concept has been a staple of science fiction for decades, and for good reason. It taps into our deepest desires and most profound questions about life, death, and the nature of existence itself. Think about your favorite sci-fi stories. Chances are at least one of them features some form of cryogenic sleep. From 2001: A Space Odyssey to Alien to Interstellar, the idea of suspended animation has captured our collective imagination, and it's not hard to see why. These stories don't just excite us with visions of future technology. They force us to grapple with fundamental questions about what it means to be human. If we could pause our lives and wake up in a different era, would we still be the same person? How would our relationships change? What would it be like to watch the world move on without us? It's a concept that's both thrilling and terrifying, promising unimaginable possibilities while also challenging our most basic assumptions about life and death. And that's exactly what makes it so fascinating. But cryogenic sleep isn't just about individual experiences. it has the potential to reshape society as we know it. Imagine a world where death is no longer an inevitability, but a choice, where we could choose to skip ahead to a future we've always dreamed of seeing, where the boundaries of human lifespan are no longer fixed. It's a future that's both exciting and daunting. On one hand, the ability to extend life indefinitely could lead to incredible advancements in knowledge and understanding. Imagine scientists being able to continue their work for centuries, or great minds from different eras collaborating across time. On the other hand, it raises some pretty heavy ethical questions. Who gets access to this technology? How would it affect our already strained resources? And what about the natural cycle of life and death that has shaped our world for millennia? Those are big questions, and they're just the tip of the iceberg when it comes to the implications of cryogenic sleep. But that's what makes this field so exciting. It's not just about the technology itself, it's about reimagining what's possible for humanity. Do you think cryogenic sleep is the technology we will need to finally get humanity to explore the farthest stellar systems? I'd like to know your thoughts below. Going back, as we get deeper into this rabbit hole, we start to realize that this isn't just about taking really long naps. We're talking about pushing the boundaries of science, challenging our understanding of life and death, and potentially rewriting the rules of human existence. Let's start with the nitty-gritty science behind slowing down life. When we talk about cryogenic sleep, we're essentially discussing the idea of drastically reducing metabolic rates. Think of your body as a bustling city. Normally, it's full of activity, cells dividing, proteins being made, energy being consumed. Now, imagine if we could slow all that down to a crawl, like someone hit the slow motion button on the entire city. This is where things get really cool. By lowering the body's temperature and using special chemicals called cryoprotectants, scientists hope to put the body into suspended animation. It's like pressing pause on your biological processes, freezing you in time without actually freezing your cells. Hold your horses though. We're not talking about slowing things down a little bit. We're talking about reducing metabolic rates to less than 10% of normal. At these levels, the body's need for oxygen plummets, cellular damage from things like oxidative stress slows to a crawl, and the aging process itself might grind to a halt. The real challenge isn't just putting someone into this state, it's bringing them back out again. We're not saving clearance sale meat and saving them in the freezer to be thawed whenever we want to barbecue. The goal is to be able to wake up from this state and carry on as if nothing happened. Rewarming a body from such low temperatures without causing damage is a massive challenge. Scientists are exploring various techniques to tackle this problem, from developing better cryoprotectants to experimenting with controlled rewarming processes. Some researchers are even looking into the possibility of using nanotechnology to prevent ice crystal formation at the cellular level. It's like giving each of your cells its own tiny space heater. How cool is that? But let's take a step back from the technical details for a moment and consider the bigger picture. If we actually manage to make cryogenic sleep a reality, we're not just creating a new technology, we're fundamentally altering our relationship with mortality itself. Think about it. Throughout human history, death has been the one true constant. No matter who you were or what you did, eventually the Grim Reaper would come knocking. But with cryogenic sleep, we're essentially telling death to take a number and wait its turn. This raises some pretty mind-bending ethical questions. If we can pause our biological processes indefinitely, what does that mean for our understanding of life and death? Are you still alive if you're in a state of suspended animation? If you choose to enter cryogenic sleep, are you technically dying or just taking a really long nap? And let's not forget about the societal implications. Who gets access to this technology? Will it only be available to the wealthy elite, creating a new form of immortality-based class divide? Or could it be used to preserve people with terminal illnesses until cures are found, potentially saving millions of lives? These aren't just hypothetical questions for philosophers to ponder over coffee. As we get closer to making cryogenic sleep a reality, we'll need to grapple with these issues head-on. We'll need to rewrite laws, update ethical guidelines, and maybe even reconsider our entire concept of human rights. But it's not all heavy ethical dilemmas and existential crises. The potential benefits of cryogenic sleep are truly mind-boggling. Imagine being able to travel to distant stars, knowing that even if the journey takes centuries, you'll arrive as young and sprightly as the day you left. Picture a world where the greatest minds of every generation could be preserved, creating a brain trust that spans millennia. And let's not forget about the medical applications. Cryogenic sleep could revolutionize emergency medicine, giving doctors precious extra time to treat critically injured patients. It could allow people with incurable diseases to sleep until a cure is found. It might even help us unlock the secrets of aging itself. As we develop these technologies, we'll need to be incredibly careful about how we use them. The ability to cheat death is a power that could easily be abused, and we'll need robust ethical frameworks and legal systems to ensure it's used responsibly. But here's the thing. Even if we never quite achieve the sci-fi dream of popping into a cryo-sleep pod and waking up centuries later, the research itself is incredibly valuable. The work being done in cryobiology is already yielding benefits in fields like organ transplantation and fertility treatment. Every sleep we take towards understanding how to preserve and revive biological tissue brings us closer to breakthroughs that could save countless lives. And let's be honest, isn't there something incredibly human about this whole endeavor? Throughout history, we've pushed boundaries, explored the unknown, and reached for the seemingly impossible. From the first humans who dared to sail beyond the horizon to the pioneers of space travel, we've always been driven by the desire to go further, to see what's just beyond our grasp. Cryogenic sleep represents the next frontier in this grand human adventure. It's a testament to our ingenuity, our curiosity, and our relentless drive to overcome our limitations. Whether or not we ever achieve true suspended animation, the journey itself is reshaping our understanding of life, death, and what it means to be human. Now that we've explored the mind-bending science of ethics in cryogenic sleep, let's blast off into the future and see how this technology could revolutionize space exploration. First off, let's address the elephant in the room, or should I say the astronaut in the spaceship. Space is big, like really, really big. Even our closest planetary neighbor, Mars, is a minimum of 33.9 million miles away. With our current technology, a trip to the red planet would take about 7 months. That's a long time to be cooped up in a tin can hurtling through the void of space. But what if we could sleep through that journey? Cryogenic sleep could turn that 7-month slog into the equivalent of an overnight flight. Imagine boarding your spacecraft, settling into your high-tech cryopod, and then, bam, you're waking up on Mars, ready to take your first steps on an alien world. No space madness, no muscle atrophy from months of low gravity, no worries about running out of freeze-dried ice cream. It's the ultimate fast-forward button for space travel. But Mars is just the beginning. With cryogenic sleep, suddenly the entire solar system becomes our playground. Want to check out the rings of Saturn up close? How about taking a dip in the potential subsurface oceans of Europa? Or maybe you're feeling really adventurous and want to venture beyond our solar system to explore distant exoplanets. With suspended animation, these become more than just pipe dreams, they become possibilities. The benefits for space exploration go way beyond just making the journey more comfortable. Cryogenic sleep could solve a whole host of problems that currently make long-distance space travel a logistical nightmare. For starters, it would drastically reduce the amount of supplies needed for long missions. Food, water, oxygen, all the essentials that make up precious cargo space could be minimized if the crew were in suspended animation for most of the journey. This means smaller, lighter spacecraft, which in turn means less fuel needed for launch and travel. It's a win-win situation that could make interplanetary missions much more feasible and cost-effective. Then there's the issue of radiation exposure. Space is basically a cosmic obstacle course of harmful radiation that can wreak havoc on the human body over long periods. But if astronauts were in a state of suspended animation, their cells wouldn't be dividing and would be less susceptible to radiation damage. It's like hitting the pause button on your body's vulnerability to the deadly rays of space. But here's where it gets really weird. Cryogenic sleep could potentially allow us interstellar travel. With our current technology, it would take tens of thousands of years to get to Alpha Centauri, which is a staggering 4.37 light-years away. Suddenly, a journey of millennia becomes possible within a single human lifetime. Imagine a generation ship, but instead of generations living and dying on the journey, the original crew arrives at their destination as fresh as the day they left Earth. It's a concept that takes us from the realm of space exploration into the domain of galactic colonization. We're not just talking about visiting other worlds anymore. We're talking about spreading humanity across the stars. Of course, all this comes with some pretty hefty technological and philosophical baggage. The engineering challenges of building spacecraft capable of sustaining cryogenic sleep pods for decades or even centuries are mind-boggling. We need to develop ultra-reliable life support systems, fail-safe wake-up protocols, and probably some form of artificial intelligence to monitor and maintain the ship during its long journey. And let's not forget the psychological impact. How would it feel to step in a cryopod on Earth, knowing that when you wake up, everyone and everything you've ever known will be long gone? Would you still be the same person after sleeping through decades or centuries? These are questions that cut to the very heart of human identity and consciousness. But that's what makes this field so exciting. It's not just about overcoming technical challenges. It's about pushing the boundaries of what we consider possible for humanity. It's about reimagining our place in the universe and our potential as a species. Think about it. Throughout history, every major advance in transportation technology has reshaped our world. The invention of the wheel, the development of seafaring ships, the advent of air travel. Each of these opened up new horizons and changed the course of human civilization. Cryogenic sleep and long-distance space travel could be the next step in this grand journey of exploration and discovery. But even as we dream of traversing the cosmos, the research into cryogenic sleep is already yielding benefits right here on Earth. The techniques being developed for preserving and reviving human tissue could revolutionize fields like emergency medicine and organ transplantation. Imagine if we could put severely injured patients into a state of suspended animation, giving doctors precious extra time to treat life-threatening conditions. Or think about the possibilities for organ donation if we could preserve organs indefinitely without degradation. And let's not forget about the potential applications in the fight against aging and age-related diseases. The more we understand about slowing down biological processes, the closer we get to unraveling the mysteries of aging itself. Could the fountain of youth be hiding in a cryogenic sleep pod? As we stand on the brink of these incredible possibilities, it's important to remember that we're not just developing new technologies, we're shaping the future of our species. The choices we make now about how to develop and use cryogenic sleep will have profound implications for generations to come. Will we use this technology to push the boundaries of space exploration, to spread humanity across the stars? Will we use it to extend human lifespans, potentially creating a world where death becomes optional rather than inevitable? Or will we find new applications that we can't even imagine yet? Whatever the future holds, one thing is certain. The journey from science fiction to science fact is well underway. Cryogenic sleep represents more than just a cool technology. It's a testament to human ingenuity, our relentless curiosity, and our eternal drive to overcome our limitations. Today's topic is definitely cool, but what's cooler is your support to the channel. Leave a like if you liked today's video and subscribe if you want to hear more about awesome technologies. Until next time, Space Cowboys, stay insanely curious.